All right, what are the zeros, roots, or x-intercepts of each function? So zeros and roots kind of mean the same thing. It's if you plug in a 0 to the function, 3 times 0 plus 4, or not necessarily, it'll end up with 0. So if you plug in 0, that's not a 0, because 3 times 0 plus 4 is 4. You need it to end up equaling 0. If the numbers are real, they're also called x-intercepts. They cross the x-axis. So what you do with these is you just set the function to 0 and solve it. So this one's fairly easy. You just apply your methods of solving functions. Depending on the function, there's lots of different methods. And so x is equal to negative 4/3. You might have known that immediately. So if you plug negative 4/3 into this function here, for x, you will get 0, which is also called a root, which is also an x-intercept because the number is real. And it doesn't matter the function. So if you look at 2, you've got the square root of x minus 7 equaling 0. And so you apply your rules of solving this particular function. This is a different type of function. It's a square root function. Well, to get rid of a radical, you square it on both sides. Whatever you do to the left, you do to the right. That crosses out your radical, and you have x minus 7 equals 0, because 0 squared is still 0. You add the 7 over, and your root is 7. So if you plug that back in, square root of 7 minus 7 is indeed the square root of 0, which the square root of 0 is 0. So that is your root. I also might point out each of these has a 1 in the as a degree, as an highest exponent. That means we only have one root. We only have 1 0. If you come down to problem 3 now we have 2 roots. You could use the quadratic formula here. However, I noticed this thing probably factors fairly simply, and most of them do in an intro to algebra course. So let's go ahead and factor this thing. So the plus minus here, plus minus right here and here, means we're also going to have plus minus in here, or minus plus, doesn't matter the order, but based on the commutative property. So then x squared, well, x squared is 1x and 1x, you don't need the 1. And 14 is either 14 and 1 or 2 and 7. We're going to go ahead and put in a 7 here, 7 here and a 2 here, so that I end up with a 5. Because if you check this, that right there is 7x, and if you check the outside 2, that's negative 2x. So we got 7x minus 2x, which is indeed 5x, and those match. So this is factored correctly, and we'll just set that to 0. So we have, so now you have either this part here, let me do a different color. Either the x plus 7 is 0 or the x minus 2 is 0. So you'd have x plus 7 equals 0 or x minus 2 equals 0. And you solve both of those. This one would be negative 7. This would be positive 2. Again, I'm kind of running out of room, but all I'm doing is adding the 2 across if you're not sure what I'm doing. So those are our, and also the 7, minus 7, minus 7. You end up with those 2 roots. So if you plug in 2, and it's pretty easy to find, this would be 2 squared, which would be 4. 5 times 2 is 10, that's 14. 14 minus 4 equals 0. So that, we know that we verified it with 2. It'll be the same if we plug in the 7. Okay. So now let's look at 4 here. Again, we've got 2 roots. So and you've got 3x here. Again, I said you could use the quadratic formula, but you don't have to. And this is what I mean by the quadratic formula. You can use that. In this case, a is 1, b is 3, c would be 0 because there's no c value here. That's for a different video if you're not sure what I'm talking about there. But what we're going to do here instead is factor it again. So this thing factors. And so here we go. So what's nice is you got an x squared and a 3x. So I'm going to reverse the distribution process and take an x out. So if you take an x out of x squared, you're left with x. If you take an x out of 3x, you're left with 3. And we need that function now, this new function we've created out of that reverse distribution process to equal 0. So that means either the front is equal to 0, so x equals 0, or the x plus 3 equals 0, just like what we did above. And if you solve this bottom one, minus 3, so x is equal to negative 3. So you either have this, negative 3, or 0. And again, plug them in to see if you get 0. You should end up with 0 if you plug both of those in. And we found both of our answers. Now, if you get down to 5, notice now we have 3 possible zeros. So what you do here is very similar to factoring. We're going to guess and check. And you look at the 18, and it's either 1 and 18, it's 2 and 9, it's 3 and 6, or or that's it. Just those possibilities. And then 2 is 2 and 1. What you're going to do is divide to get all the possibilities for factoring. We're not going to factor it. We're just going to find all possibilities. You take the back number and divide it by the front number. So that would be, and it's always going to be either positive or negative of that. So if you took the 1 divided by 1, you get 1. You take the 1 divided by 2, and you get plus or minus 1/2. That's a possibility. We've got them all then. You get the 2, now you look at the 2. Plus or minus 2 divided by 1. And then plus or minus 2 divided by 2, I'll write it down, but you don't need to. That's 1. We already have it, so we don't need that one. Then we go on to 3. Plus or minus 3 divided by 1. Plus or minus 3 divided by 2. That's all my possibilities for 3. Go on to 18. Plus or minus 18 divided by 1. Plus or minus 18 divided by 2, which is 9. 9. And then you go on to 9. Plus or minus 9 divided by 1, plus or minus 9 divided by 2, and then you go on to 6, plus or minus 6 divided by 1, and plus or minus 6 divided by 2. I'll write it down here. Again, that's 3. We already have it right here. So you can, maybe I should change my color so you can see what I did there. There's 3, 6, those are the same, so you really don't need that one. So we have all of these possibilities. And what you do is you just start with the easiest one and work through your list until you find one. Usually in a college algebra course, you're going to find one. Possibility is that only one of these work, or maybe 3 of these work, or maybe none of these work. So we don't know, but it gives us a place to start. And if you notice down here, I've plugged in a -1. And so I always start with plus or minus 1, then I move on to plus or minus 2, and I just plug them in. You can see that 1 doesn't work, so let's try 1. So it would be 2 times 1 cubed minus 13 times 1 plus 3 times 1 plus 18 equals 0. And so that's 2 minus 13 plus 3 minus 18, or plus 18, excuse me. And if you add those up, you've got 2, sorry, this one was squared, not that it matters, but 2 minus 13 is -11 plus 3, not -18. So that is not 0, so not equal to 0. Down here below, you plug in a -1 then, and you notice that you've got, that 18 is hard to read, you've got -2 minus 13, because the -1 squared is 1, minus 3 plus 18. Well, all of these are -18. Plus 18 does indeed equal 0. So -1 is one of our roots. So to find our other two roots, and I'm kind of running out of room, is you go ahead and synthetically divide our function. So we need the 2, the negative 13, and I'll get them from here. 2, negative 13, 3, and 18. And that'll get us down to a quadratic. So that would be 2, you bring down your first term, you multiply the 2 and negative 1, and you get negative 2. That would be negative 15. You multiply those, you get 15. That's 18. 18 times negative 1 is negative 18, and you get 0. So we've got a function now of 2x squared minus 15x plus 18 equals 0. So we can now find the function there with the quadratic formula or by factoring. And I know that this one factors, so that's kind of nice. But so I'm going to factor it just to save time. But you may not want to spend your time messing with factoring it. But I'm going to do that just because I know it factors. So minus plus is minus minus. You'd have 2x and 1x for the front part. And 18 is either 6 and 3, 9 and 2. I'm going to go ahead and pick 6 and 3. You know, I kind of know I know that it factors. You might not have known this, and definitely go back to the quadratic formula if you don't want to mess with this. But then this one factors. If you check the middle 2, we've got negative 3x. If you check the outside 2, we got negative 12x. That's indeed negative 15x. So you set both of those to 0, and I'm out of room. I don't want to mess up my stuff in the bottom. So you go 2x minus 3 equals 0, and x minus 6 equals 0. And so this one is 6. This one is 3/2. And again, I'm skipping some steps there because it's the same as above. So now we know all three of our roots. Our roots are 3/2, which was on our list, 6, which was on our list, and negative 1, which was on our list. So all three of them happen to be on our list. They could have been imaginary. They could have been irrational. We don't know until we dive into this. But for now, you're probably going to find on every single one of these that I give you, you're going to find at least one root that works. Okay. So that's finding the zeros. But what happens if you go the other way? So given the two roots of the function are 7 and 2i, find a polynomial function that has these roots. So in other words, I've given you the roots. So one of my roots is 7, one of my roots is 2i. Well, imaginary numbers come in pairs. So it's 2i and also negative 2i. It's always the conjugate of the imaginary. And I picked kind of easy ones. So we know we have actually 3 roots for this polynomial function. So just like factoring, x minus, x, here I've got 2x minus 3 and x minus 6 here. And that is positive 6. You can set it up into a factoring. These are called linear factors. But I know that this thing is x minus 7 times x minus 2i times x plus 2i. Now just a little handy trick. Imagine or multiply those first. So multiply these first. And so what you have here is, and it'll eliminate your imaginary numbers because they're conjugates, just as for your information in future problems. But you just distribute. You might have called this FOIL depending on your teacher, but that's x squared plus 2xi minus 2xi minus 4i squared. Or maybe you have a calculator that can do these for you, however you have it. Well, these two in the middle cross out. That's 0. Not always does that happen, but here it does because they're conjugates. I squared is negative 1, hopefully. And so this is negative 4 times negative 1, which is positive 4. So this thing becomes x squared plus 4 times x minus 7. And then you just FOIL it again. So x cubed plus 4x minus 7x squared minus 28. And so this is a possible, whoops, I'm putting them in descending order. This is a possible polynomial. Now, until we have a point that represents the function, we really don't know which polynomial it is. Like, you might, if f of 0 gives you 28, negative 28, then this is the polynomial for that function. But you need really a point to calculate the rest of it, and that's beyond this video. I'm just trying to give you just a rundown of the entire polynomial process in a really fast grouping. I've talked too fast, but that's pretty much it. There's more to it. There's nuances that we needed to explore, but that's the nuts and bolts of zeros of a polynomial. So hope this helps, and I'll see you next time.